All right, this is the video for handling the second portion of the 3.1 chain rule practice DeltaMath assignment. And so now we're going to start, we've looked at chain rule, we're going to start intermixing it with other derivative rules. So let's go ahead and start with multiple derivative rules. All right, so given the function y equals 2x sine of 2 plus 5x, find dy dx in any form. So first and foremost, notice a couple of things. I'm going to have to use chain rule at some point because I have a 2 plus 5x inside of a sine function. And then I also have this sine function multiplying this 2x. So I'm going to actually start my product rule. So I'll make my f, my 2x, that makes f prime 2. And then for my g function, that's sine of 2 plus 5x. And to find g prime, I'm going to have to use the chain rule. So for my chain rule, I'm going to do my outer function is sine of x. My inner function is 2 plus 5x. Derivative of sine is cosine. Derivative of 2 plus 5x is just 5. So derivative of the outside, keep my inside the same, times the derivative of the inside. So I'd end up getting 5 cosine of 2 plus 5x. Oh, that should have been in green. Oh well. So then now when I finish off my product rule, crisscross add all sauce, so my final answer will be 2x times 5 cosine 2 plus 5x would be 10x. So we get 10x cosine of 2 plus 5x plus 2 sine of 2 plus 5x. And so then I can go ahead and write that all in here, and hopefully it will accept that as a form. Very good. All right, let's do one more of those because they can be a little tricky. Oh geez, so this one it looks like I have a giant square root function and then it's surrounding a quotient. So I think I'm going to have to use quotient rule and chain rule here. Let's clear off my screen. Okay. So if I start off my chain rule is happening first because I have an very clear outer function and inner function. So my outer function is square root x, or x to the 1/2 if you prefer that. And then my inner function is 6x over 1 plus 4x squared. To find the derivative of my outer function, this is one we use often enough that this is probably going to be stuck in your memory, but worst case scenario, you can always do this and then move your x to the denominator and then it'll be 1/2, so square root. And then to find the derivative of your inner function, I actually have to use quotient rule. So I'm just going to sidestep real quick and do my quotient rule for that. So my low function, d high, the derivative of my upper function is 6, minus high, my upper function, d low, the derivative of my lower function, which would be 8x, all over low squared, 1. There we go. And this one actually seems pretty easy to simplify in the top, so I'm going to go ahead and do that. I don't know if the DeltaMath will accept it, but we're going to try it. So 6 plus 24x squared minus 48x squared, right? 6 times 8, yep. All over 1 plus 4x squared. So that's going to be my, well, negative 48. So then I'll put negative 24x squared plus 6 over 1 plus 4x squared. Oh, squared. Low squared. There we go. All right. So I'm going to go ahead and I use my quotient rule to find that. So now I'm going to finish my chain rule and then we'll see if we can type it all in. So derivative of the outside, keep my inside the same, times the derivative of the inside. So 1 over 2 times 6x 1 plus 4x squared, all times negative 24x squared plus 6 over 1 plus 4x squared. And it says it'll take it in any form, so let's see. that to be over. If you highlight something and then hit the division sign, it'll divide everything you highlighted, not just the x, or not just the 6. Okay, times. So again, I want to divide all of that stuff by something. 1 plus 4 squared. Let's see. Oh, it likes it. That's fine. Oh, so they even went as far as to, they didn't simplify using radicals, and they didn't simplify any of my quotient rule. So I guess you could do that too if you really wanted to. Yikes. All right, let's go ahead and look at trig rules, or trig derivatives with chain rule. Oh, some of these you don't even need to use chain rule for, but I think it's because I make you memorize all of the trig derivatives, and they don't necessarily need you to memorize all of them. So I guess this would be good practice in general. So cosecant is one of the ones you have to memorize. So the derivative of cosecant is negative cosecant cotangent. So this derivative would just be negative 2 cosecant cotangent. See, they actually, oh, I don't know, no chain rule needed. Oh, okay, see. How about in this one? Yes, in this one you would need the chain rule, and the difference is because you have stuff inside of your cosecant function. So my outer would be 3 cosecant. My inner would be 2x. Derivative of the outside would be negative 3 cosecant cotangent. Derivative of the inside would be 2. So derivative of the outside, keep my inside the same, times the derivative of the inside. So this 2 is going to multiply all this stuff. So 2 times negative 3 would give me negative 6 cosecant, keep my inside the same, and you have to do it in both the pieces, right? These are the places where your inside was happening originally. So those are the places where your inside function still has to be. Ooh. Here, we'll try one more. Oh, this one's easy. You have to know the derivative of tangent is secant squared. So, stuff like that. All right, last one, derivative rules with tables of values. Okay, so this one, it's easiest to write out the rule you're trying to find first and then plug everything in. Actually, that's how you have to do it, so make sure you're following that. So use a chart to find h prime of 3 in its simplest form. So h of x equals f of g of x. So this is a chain rule. So first of all, if I'm going to find h prime of 3, I need to find h prime of x first. So h prime of x would be derivative of the outside, keep my inside the same, times the derivative of the inside, right? That's our chain rule itself. So then when I find h prime of 3, I'm finding f prime of g of 3 times g prime of 3. Prime g of 3, so if I go to g of 3 on my table, figure out where they match, so g of 3 is negative 9. And then g prime of 3, here's my g prime of 3 is negative 12. And then last but not least, f prime of negative 9, so f prime of negative 9 is negative 1. Negative 1 times negative 12 gives me just a positive 12. Very good. Look, they did the same way I did. All right, let's try another one. All right, so this one we have h prime of 5. That's what they're trying to ask us to find, and h of x is a quotient. So if I'm going to do h prime of x, I have to do low d high, derivative of your upper function, minus high d low, all over low squared. All right, so now if I'm finding h prime of 5, I'm just going to plug in a 5 everywhere. G of 5, f prime of 5, minus f of 5, g prime of 5, all over g of 5 squared. All right, g of 5 is 1. F prime of 5 is negative 7, minus f of 5 is positive 7. G prime of 5 is negative 6. all over g of 5 squared. G of 5 was 1, 1 squared is 1. So I'll get 1 times negative 7 is negative 7. Negative 7 times negative 6 is a positive 42 all over 1. So 42 minus 7 would be 35 over 1. Boom. Don't try to do these ones in your head. It's easier if you write it out, I promise. Just find some scrap paper. All right, so that is 3.1 chain rule practice, the rest of it. Let me know if you have any questions.